G'day, my name is Alexander Kilpatrick. Today I'm going to be talking about the attentional optimization hypothesis. This research is currently under review and it's been produced with my colleague Ricky Bangard-Nielsen. Now, there's something that's always interested me about the 7-Eleven logo, which despite being owned by a multinational, multi-billion dollar company, appears to have a mistake in it. The first few letters of the word 11 all appear to be uniform. They're in the same font. They're all uppercase, while the N is not. Now, this isn't a mistake. In design and marketing, this is known as a blickfang, which comes from Danish, meaning eye catcher. And the thing about blickfangs is that once you see one of them, you then tend to see all of them. So here's an example series. Now, these design elements kind of rely on our natural reaction to unexpected or unpredictable stimuli. There's been a wealth of knowledge on how we deal with things that are unexpected. However, the short story here is that when something is surprising, it tends to capture our attention. It tends to be more cognitively demanding, and also we tend to better encode it into long-term memory. So it's more memorable. Now, in this study, what we're looking at is the potential that certain words in here, we're talking about American English, operate as blickfangs. So essentially, whether the relationship between semantic vividness and the predictability of phonemes within a word are related, whether there's a positive correlation between those two variables. Another way of looking at this is to frame it using the work of George Kinsey-Zipf, who taught us that languages tend to be economical. We construct them in a way so that resources are not wasted. However, this research is kind of showing, well, sometimes languages aren't economical. Sometimes they're loud. So we need to talk about the calculation of predictability of phonemes. And to do this, what we've done is we've developed average phonemic bigram surprisal. We start by defining what is the chance of one phoneme following another. And to do that, we took the Supplex US, which is a very large corpus of spoken American English. We cross-referenced that with the CMU pronouncing dictionary, which gives us a phonemic transcription of those words. And using those two data sets, we can calculate the percentage chance of any phoneme following another. And we framed this study in information theory, which was developed in the 1940s by Claude Shannon, who developed information theory essentially to quantify how much information is being expressed in a communication system at any given time. And that amount of information is determined by probabilities. So here we're using surprisal, which is the negative log squared of the probability, in this case, of one phoneme following another. And obviously that gets averaged out across a word. Now, the word blickfang is a slightly higher than average surprisal word. It's about 5.5, whereas most words in American English are about 4.5. And it's mostly because of this mountain here in the middle from the KF bigram. Now, this is not uncommon for English words because we have some very rare bigrams that only occur at morpheme boundaries. So we need to account for morphemes in the models, which we do in the models that I'll present later. So what have we learned from this measure? Well, first of all, we were using it to kind of look at processing difficulty, right? Like, are high surprisal words more difficult to process? And that was what we found. What we found using a lexical decision task and a read aloud task was that words with high surprisal tend to be, they received less accurate results for those two tests, and they also had higher response times. And both of those measures were significant, suggesting that they were more difficult to process. However, we also used a series of memory recognition experiments, and those showed us that words with high surprisal, despite being more difficult to process, were better remembered in that memory recognition experiment. So we considered the option that potentially average phonemic bigram surprisal might be one of the ways that words can be phonologically marked in language. And if so, well, then that gives us a quantifiable metric for phonological markedness. So we were looking at that potential and we considered the negativity bias. The negativity bias is a very well established concept in psychology. And we know that essentially negative events and stimuli, they tend to attract our attention better, and they are also better remembered in long-term memory. We tend to, preference negative events over positive events, especially when we're young. This effect tends to decrease as we age. So for that relationship between, and that's what we found. We found a relationship between negative valence and increased surprisal in words. And we considered two potential reasons for this. The first is that negative words are less susceptible to change, because if you change the word for a dangerous referent, then you increase the opportunity for misunderstanding when something's dangerous, which is obviously a suboptimal survival strategy. We know that from Maria Flaxman's work with the iconicity treadmill hypothesis, that when words are first introduced in a language, they tend to have a high level of iconicity to them. And my work with Maria has shown that those words also tend to have high surprisal. So as words become more arbitrary over time, their surprisal also lowers. The second option is the attentional optimization theory, that certain words are strategically inefficient, that language communities have this whole other level of cooperation whereby they assign high surprisal forms to reference that are semantically vivid. So if the second of these, if there is a relationship between a positive relationship between surprisal and vividness or vividness ratings, then it can't be, or it can't solely be the first of these hypotheses. It must also be the second. So we operationalized vividness using three existing data sets where words have been given ratings according to their specificity, their imaginability, and their concreteness. And we just essentially popped those into existing models that we'd already developed for our other metrics. And we found that yes, indeed, average surprisal was associated with increased specificity, imaginability, and concreteness. What's kind of interesting about specificity, imaginability, and concreteness is we already know that these have kind of varying effects on processing and processing difficulty. So we considered, well, what about how do these two variables, surprisal and whichever of the vividness ratings we're talking about, how do they work in modeling? And so in other words, is processing difficulty more tightly linked to vividness, or is it linked to surprisal? So our first model, which showed the weakest results, this shows us that surprisal, in fact, didn't have much of an influence, right? We do see a significant increase of response time for the read aloud task, and there is the general pattern, but most of these are not significant. However, specificity, we see a decrease in accuracy and an increase in response time for the read aloud task, and a significant increase in the memory recognition experiments. Concreteness, on the other hand, we see that surprisal has a much stronger effect. These words are processed with greater difficulty due to the increased surprisal. We also see a decreased response time for the lexical decision task and a really strong effect on memory recognition for the concreteness variable. Imaginability, which has our strongest effects and I think the most interesting effects here. We see that average surprisal is linked to both increased processing difficulty and increased memory recognition, whereas imaginability shows us that words that are highly imaginable are much easier to process. We see both an increase in accuracy and a decrease in response times, and there's a really strong effect of imaginability on memory recognition. So what do these mean? The Blick Fang in the 7-Eleven logo attracts our attention, much the same way that these words with high surprisal do. However, unlike that Blick Fang, it's not a conscious effort on linguistic communities to assign high surprisal words to semantically vivid reference, right? This is an unconscious effort. The attentional optimization hypothesis proposes that this isn't by design. We don't get together and decide upon these high surprisal forms as a committee, right? This is really a remarkable cooperation amongst linguistic communities, or I should add the caveat here, this is only American English that we've conducted these tests on. We are looking at expanding it, obviously. But it seems that by assigning these high surprisal forms to these vivid words, we're kind of optimizing for perceptual salience and kind of the direction of the attention of the listener and an increased memorability and, of course, the expressive force of the words. Okay, here is a list of references. I hope that this has been at least interesting. All right, I'll catch you later.